Hi, everybody. So in this video, we're going to take a look at Module 9, which is about quantity controls or quotas. So check your understanding. Number 1 says replicate the figure 9.1 that's in the textbook. So you have to scroll back up to see what that one looks like. It's pretty detailed because it's got all these little dots and stuff on it. You don't really need to actually redraw the entire thing. There's just a few numbers on it that are actually pretty important. So I've gone ahead and done that already. I'm going to say pause this and recopy this little diagram if you haven't already, but you don't have to like do everything detailed wise. It says number 1, suppose the supply and demand for taxi rides is given by figure 9.1 and a quota is set at 6 million rides. So that's why I went ahead and added the 6 there. And then it says, identify each of the following on your graph. The price of a ride. Okay, so for A, the price of a ride is going to be determined by the demand curve. So that's the willingness to pay, right? And so if you're a taxi driver, you're going to charge what people are willing to pay, which is $7. Now B says the quota rent. Now they don't specify like whether it's per unit or total and all of that. And in fact, with the diagram, I'm not sure that it really matters. But we could just say that it's the per unit quota rent, which would be the difference between what the buyers are willing to pay, which is 7, and what the taxi drivers are willing to do it for, which is 3. And that's $4. So we'd say 7 minus 3 is $4. C says the deadweight loss. Now, I didn't talk about this in the lecture video because we're going to explore deadweight loss more in Unit 2. But deadweight loss is actually the value of the transactions that didn't happen, that should have happened in a perfectly competitive market. So like we have transactions that should occur, we should have 10 of them, and we know that only 6 did. And so there's a value to the people who are basically buying and selling taxi rides, that those taxi rides that didn't happen, we can quantify their value. And it's actually the area of this triangle. Now, I don't know about you, but it's fairly straightforward to do 1/2 times base times height. And so, if we think about that, this is actually 2 triangles. There's one here and there's one here. Now, these 2 are identical in size, but they won't necessarily always be identical. So it's a good idea to calculate the area of this first triangle. We'll say like triangle A and then triangle B, just to make sure that you're doing it correctly. So 1/2 base times height, right, is our triangle size. And so the base of that triangle is 4. We can say 10 minus 6. And the height of the triangle is 2. So 4 times 2, right? So base 4 times 2 times 1/2, and that's equal to 4. Now there's 2 of these triangles and they are identical in size, so times 2 is 8. And these are actually in dollars as well because it's the quantifiable dollar value of the transactions that don't happen. Then it says D, suppose the quota on taxi rides goes up to 9 million, what happens to the quota rent and the deadweight loss? So we don't actually need the numbers here. We can just kind of visualize what would it be like if that line, instead of it being here, if it were set to here, well, what would happen to the deadweight loss? We could say that that size of that triangle would get smaller, right? Because it's be really tiny. And then what would also happen to the quota rent? Well, the quota rent would also get smaller on a per unit basis or on the entire. Now it says number 2, again, replicate the graph from figure 9.1. I'm going to go ahead and skip doing that because you don't really need it for this. And it says, suppose that the quota is 8 million now. They're going to keep changing it around on us. And the demand decreases due to a decline in tourism. And then it says, show in your graph the smallest parallel leftward shift of the demand curve that would result in the quota no longer having an effect. So we'll just kind of do a little dotted line here for that 8th one. And if the demand curve shifts to the left so that it's no longer effective, then it would be all the way to here, right? So that would be if your curve kind of shifts so that this point right here is the new equilibrium. And that would mean that quota doesn't have an effect because the new market equilibrium is at 8. So if the demand decreased and the new equilibrium is at 8 instead of 10, then the quota has no effect. So we're just going to check that one there. Now, multiple choice number 1 says, if the government established a quota of 1,000 in this market, the demand price would be, and all they're asking there is like, what would the demand curve price be? At 1,000, it's 8, so 1 is D. And so it's kind of like asking, What's the demand price in this one? Originally, it would have been 7, right? And that was what our answer was for A. Number 2, if the government established a quota of 1,000, the supply price, again, what would they be willing to supply it for? If we look at that graph down there, it should be 4, and so that's B. Again, we're just looking at like the price on the supply curve for it. If the government established a quota of 1,000, the quota rent would be, and again, the vertical distance between 8 and 4, 8 minus 4 is 4. So the correct answer is B. Number 4, quotas lead to which of the following? Inefficiency, yeah, we know that, right? Because there's missed transactions. Incentives to evade or break the wall, yeah, there sure are. And a surplus in the market. It's not going to create a surplus, it's going to create a shortage. There's going to be more people who want the good than are kind of able to get it, at least a shortage compared to the market equilibrium is a better way to say that. So we would just say D for this one, 1 and 2 only. And number 5, let's scroll down, which of the following would decrease the effect of a quota on the market? A decrease in demand, yeah, because we actually saw that in number 2, right? We saw that the quota wouldn't be as effective. And then increase in supply, no, that would make the problem worse. Increase in demand would make the problem worse. A price ceiling above that doesn't even have any effect. The D doesn't do anything. And E, none of the above, well, that's not true. So a decrease in demand is the correct answer. Okay, now let's take a look at number 2 for response. Draw a correctly labeled graph of the market for taxis. Draw and label a vertical showing the quota, demand price, supply price, quota rent. Well, that's kind of what we already did, but all right, let's do this one here. Q, P, demand, supply. They aren't asking for this, but I'm just going to put this is Q star, P star, and then we just draw a quota, right? And here is the supply price because it's the price on the supply curve. And here's the demand price because that's the price on the demand curve. And quota rent is the difference between the two. All right, hopefully that helped you. I'll see you next time. Bye now.